Unit 5, Lesson 5, annuities. So we've done compound interest. We've practiced compound interest, both accumulated amount and present value. An annuity is a little bit different than just plain old compound interest. An annuity is a series of equal deposits. So you're putting money into something, into an investment made at regular time intervals. Each month, each year, each week. For example, an investment of $100 per month each month for 10 years. You're investing the same amount, $100, every month at a regular interval. So the amount of annuity is the value of all of those deposits, all of those contributions at the end of the time frame. So at the end of the annuity. The formula for future value of annuity is this. Future value is R, where R is the amount of the regular deposit. I is your interest rate, just like with compound interest. It's got to be adjusted per compounding period. And N is the number of deposits made. And that's got to be adjusted for your compounding, or adjusted for your deposits. Make note, the formula can only be used if the depositing frequency is the same as the compounding frequency. So you have to deposit each year and get compound interest each year, or you have to deposit semi-annually and get compound interest semi-annually. They have to be the same to use the formula. So example 1, I'm just going to write the formula down here before we go any further. R, whoops, 1 plus I to the exponent n minus 1 over I. So fairly complicated formula. It's going to be important that you have a calculator and that you practice and you know how to use your calculator, because I'm not going to teach you how to use your calculator the day of the test. So if I want to determine the amount of annuity, when you deposit $500 at the end of each year for the next 20 years and the interest rate is 5% compounded annually, the first payment will be made 1 year from now. So I want the value when my R is $500. I've got 1 plus my interest rate. It's compounded annually, so it's just 0.05. And for, where did I see it? Next 20 years. So N is 20. Take away 1. Here we go. Our interest rate, 0.05. So to enter that in your calculator, you can enter the whole numerator and then hit equals, and then do your divide by 0.05. You can do BEDMAS, where you do the work in the brackets, your exponent, subtract 1 times by 500, hit equals, and then divide by 0.05, whatever way makes the most sense to you. So let's see if we can get the same answer. Equals that, minus 1, equals that. There we go, divide by 5. So I have got $16,532.98, which should make sense. $500 each year for 20 years. If I did 500 times 20, that would be 10,000. So I should have more than that because I'm getting interest on top of my deposits. All right, let's try another one. Oh, I should have written my formula down again. So future value is R. I have to remember my formula. 1 plus I to the n minus 1. 1 plus I to the n minus 1 over I. Okay. So determine the amount of an annuity of $1,000 deposited semi-annually for the next 10 years. The interest rate is 3%, compounded semi-annually, and the first payment will be made 6 months from now. So my payment, my R, is $1,000. I have 1 plus my interest rate, because it's compounded semi-annually. I have to take my interest rate and divide it by 2, just like with compound interest. Semi-annually for 10 years. 10 times 2 is 20 for my N. And then I divide by 0.03 over 2, my interest rate. So be careful, as they get more complicated, they get more tricky to enter in your calculator. You can enter your whole numerator again, hit equals, and then divide by and put brackets around your denominator, and then hit equals. That's probably the best way to do it. Play around with it until you're able to get the correct answer. So I'm going to take a minute here and get the answer. We have got 2 plus 1, exponent 20, that minus 1, is that times 8, divide bracket, 2 bracket. So I have got $23,123.67 is the value if I deposit $1,000 twice a year for 10 years. And that makes sense because $1,000 twice a year for 10 years would be about $20,000 without any interest. All right, my last example. So I'm fairly certain you guys all want to be millionaires. So this is for you. Common strategy to build wealth for retirement is to pay yourself first. This means take 10% of your monthly income and invest it before you spend any. If you took $300 each month from the age of 25 to the age of 65 and invested as 5% compounded monthly, how much would you have to retire? So our R is $300 each month. Our interest rate is 5% compounded monthly. So 0.05 divided by 12. And 25 to 65. So that means over 40 years compounded monthly. Excuse me, it's 40 times 12 will be 480. So my N would be 480. All of that divided by 0.05 over 12. All right, calculator time. So all right, what did you get? I got $457,806.05. That's what I got. $457,806.05. And there it is. So that leaves you guys with some of your own to try to make sure you know how to use this formula and how to use your calculator for it.